Section 7.2 is operations on decimals. And the first operation that we're going to take a look at is actually the two operations in one. This is addition and subtraction. The basic idea of how addition and subtraction works is that we line up the decimal points and then we add or subtract the very same way as we would with whole numbers. So we're taking a look at this particular problem. What did that look like? Well, it would look like us doing 4 and 33 hundredths, and then 3 and 26 hundredths, and then we'll add them up. One way of doing it anyway, the one we're probably most familiar with, is to add them up from right to left. So 3 plus 6 is 9, 3 plus 2 is 5, bring in our decimal point, and then 4 plus 3 is 7. So pretty standard, not very complicated, that's fine. What I would like for us to consider though is, why does this work? So we're going to think of 4 and 33 hundredths as 4 plus 3 tenths plus 3 hundredths. Sort of a decimal expansion kind of view, like we did the base 10 stuff when we were looking at section 7.1. Then I've got 3 plus 2 tenths plus 6 100ths. And then we're going to add those that are the same kind of values alike. We're going to add alike the ones who are the same kind of values. So 4 plus 3, of course, is 7. And then 3 plus 10, I'm sorry, 3 over 10 plus 2 over 10 would be 5 over 10. And then the last one would be the 3 over 10 plus the 6 over 10, 3 over 100 plus 6 over 100, which would be 9 over 100. So then I have 7 and 59 hundredths. All right, so when you're working these problems, I'm not expecting you to show this why does it work business out on every problem, unless, of course, it asks you about that. You should know how to do that, but the issue is whether or not you know why it actually works. And the reason that it actually works is because of this fraction expansion business. All right, an example of a problem with addition and subtraction. A stock's price dropped from $68.28 per share to $27.45. What was the loss on a single share of stock? So as we're taking a look at this one's asking us to subtract 63 and 28 100ths minus 27 and 45 hundredths. All right, so we're going to subtract on the right. 8 minus 5, that's 3. 2 minus 4 doesn't work, so we're going to borrow. So basically we're taking like a dollar bill and turning it into 10 dimes. So this 2 becomes a 12. So 12 minus 4 would be 8. And then, of course, 2 can't subtract from 7 either, so I'm going to have to borrow again. So this one's 5 now, and this one's 12. 12 minus 7 is 5, and then 5 minus 2 is 3. So it dropped $35.83 per share. Our next operation is multiplication. So to multiply, we're going to multiply the same way we would with whole numbers. And then we're going to count the number of places after the decimal point in all factors, sort of combine those. And then that is actually the number of decimal places you'll have after your decimal point in your product. So in other words, if we took this example that's on here, we'd have 0.3 times 0.7. And we're rather going to ignore the points and just say 7 times 3, which is 21. And then notice there are 2 decimals after the decimal place, 1 in each term. So there needs to be 2 in my answer as well. So I'm going to have my decimal point and then 21. So again, why does it work? Well, let's consider writing 3 over 10 as our fraction that corresponds to 3 tenths, and the same thing for the 7 tenths. Now I know we could multiply out, things all differently and stuff, but the main idea is it's just plain old multiplication. So you've got 3 times 7, which is 21. You've got 10 times 10, which is 100. And this ends up being the same thing I had before, 21 hundredths. All right, this is our last one like this, division. This process says that we're going to make the divisor a whole number by removing the decimal point in the divisor and the dividend an equal number of times. Then we're going to divide as with whole numbers. So what does that look like? Well, it looks something like this. So we're taking our 75 with the decimal point in front of it, and we're dividing by something, in this case it's 0.5, that's on the outside. So I'm going to have to move this decimal one place over in each term in order to actually get this to be 5 that is dividing 7.5 and potentially a 0 or 2, depending on something like that. So 5 goes into 7, we'll put the decimal point in there. So 5 goes into 7 one time. 7 minus 5 is 3. This is 35. So what was this one going to be? 7? 7 times 5, that's 35. Okay, sorry about that. I had a little error going on right there with my subtraction. Let me fix that one. All right, this would have been a 2 when I subtracted. So then there's 25. So 5 goes into 5. 25. 5 goes into 25 5 times. And then 5 times 5 is 25, and we don't get a remainder. So this is actually my value to my question. And the question of why does it work or how does it work is what's coming next. So this says I'm going to take these values and I'm going to take them and I'm going to write them as a fraction. You know, sort of ignore interpreting the division sign right there is actually a fraction. And if we take a look at what's going on here, we need a whole number in the denominator. Well, you know, moving the decimal places or whatever is multiplied by 10, so we're just multiplying by 10 on top and bottom. And then this becomes 7.5 that divides by 5. And then you can divide, and then you can actually do that division exactly the same way that we did this. No difference if you like. All right, we're going to look at a couple of other topics within this section. The next one we're actually going to look at a scientific notation. Scientific notation actually looks like A times 10 to some power n. A few conditions for you. The value of A is actually between between 1 and 10, and that's really like the absolute value of A that we're talking about. So if you had a -7, that would be okay because still 7 is between 1 and 10. And the exponent, n, must be an integer. Okay, positive and negative whole numbers. And so what we're going to look at first is changing standard numeral into a scientific numeral. You're definitely going to take the decimal point and you're moving it to create that value that is between 1 and 10. And again, it might have a negative on the front, which is fine, but the value itself is between 1 and 10. Then you're going to count how many moves or times it actually took you, adjustments of this particular point and see what's going on with that. So however many moves you are tells you your exponent, but your exponent could be positive or it could be negative. So a large, larger than 10 number gives you a positive exponent. So positive exponents will occur when the numerator is considerably bigger than larger than the denominator. A negative exponent actually means that a smaller than 1 kind of number is actually the one that we would be focusing on if we had a negative exponent. Alright, so next thing we're going to do is we're going to do an example of, in fact, changing a standard numeral into scientific notation. So the first thing you'll notice is that this 298,000 needs to be 2.98. And we need to write 10 to some power, and the 10 to the power, we just count how many when we went over. So this is 3, and then 4, 5. So this would be a power of 5, and it's negative, so negative 5. Okay, let's go the other direction now. Saying scientific notation turning into standard form, or standard numeral. We're going to move the decimal point the number of places indicated in the exponent. And what you keep wanting to remind yourself is positive is negative. Okay, a positive exponent, not as negative, is a small number that gets larger. Positive exponent is a large number. And the negative, the one that I was trying to say earlier, the negative exponent is a small number. Okay. An example of that one would be this right here. Apparently I was liking the number 5, and it's the last one had a 5 in it as well. So this is 3.2. And we're going to move the decimal 5 places to the which side? Yep, left. And it's going to go to the left because we actually have a value that was supposed to be smaller than the one we started with. So we'll count. 1, 2, 3, 4, 5, 6. I got 6 of them. So we're going to take this expression and we're going to write it as though it were that case. So I've got 4 zeros and then 3, 2. And for n Kate, I have 3.2 times 10 to the negative 5th. And we have a problem. Well, it just looks messy. We don't really have a problem that looks like a mess. This would actually be our answer to this particular question as well. right, one more scientific notation problem. Because of the commutative property, we can move all the multiplications around that we'd like. And in doing so, it's often easy to look at these two numbers and actually multiply them together first. Okay. Now we're going to do the other piece. Oops, let me put that. I meant to put that. We're going to actually do the 10 to whatever power this is. So we've got the exponents there of the 10 to the 12 and then 10 to the 15. So this would be 10 to the 14, 16. What comes after 16? All right, we have 12 plus 15. That's 27. This is not quite in scientific notation because it should be 4.8 instead of 48. But as you're taking a look at that one then, we have changed our fraction into something that is larger than it was before. So that means we will increase our exponent to the 28 positive. All right, just a couple more little things before we're done with the first half of this video. Estimation. Estimation is actually done in one of two ways. One is rounding to the nearest blank, and we're going to leave that blank filled in just like that. The other is front-end estimation, where you use the first one or maybe two values, and then you dump everything else and turn them all into zeros, hence you round them off. All right, so let's take a look at rounding. Notice this first one with rounding asks you to actually look at the hundreds place. So the hundreds place is the 2 itself. So this number would be 200. How about hundredths? All right, there's the 5. And so we're going to take a look, because that's in the hundredths place, at rounding that. The next value over is a 1. So we'll round that down. So this would be 203.65. And then the units place, of course, is the 3 value itself. Looking to the right of it, that one actually means that I have to round it up. So this one becomes, 204. And that one's it for today.